In this video, I'm going to explain some of the timer settings for Direct IDE and Direct HCI mode. Now, right now I'm in pass-through mode. We'll go to this first. We look at the timer settings. We only have one timer setting, the general timeout. In pass-through mode, this general timeout is sent to the OS as a possible timeout, but I can tell you that as far as I can tell, the Linux OS always ignores this. So we can turn it down as low as 10 seconds. Right now it's set at 60, which is basically the default timeout for the operating system itself. You might as well just leave it alone, let the OS do its thing, because turning it down really doesn't do anything. And if it does, I'm not sure it would be a good thing or not, but it's never worked for me. So I'm going to switch the mode to Direct HCI. Go to the timer settings, and we see everything's lit up. So, first thing is initial busy wait time. This is, and I'm referring to my own documentation. Initial busy wait time is the amount of time that it takes or the amount of time it waits for the drive to become ready. Assume if the drive suddenly became not ready, became busy, while waiting to attempt to perform a read. In other words, when it goes to perform the read command, it checks if the drive is busy or not, and it waits this amount of time for the drive to become ready. Otherwise, it'll go into a reset sequence. And I'm not sure this says the read will be attempted after the reset. I'm not really sure my program does that or not. It's a good question. It might just be marked as bad. I can't remember, and I'm not going to go look at the code right now. The other thing to note about this timer is it also affects the wait time per device when listing the choices for the source drive. Although no reset is performed. It will not perform a reset. Like if you go and say choose a source drive, when it lists the drives, and we'll go here now. So to the source drive, when it goes to list these drives, if it hangs, that's because there's a drive that's not responding properly, and it's only this initial busy wait time for each drive, for each one of these to respond. If they hang, then it's going to take longer. Normally, you don't need, if you have a trouble listing a drive where it's not coming up correctly, you can potentially increase the initial busy wait time to aid with that. Also, I don't think I mentioned if you have a drive with a slow responding issue, a very bad slow responding issue that goes beyond this 8 seconds of the default initial busy wait time, you may want to consider turning that up to accommodate that drive. It doesn't hurt to turn it up. It just allows for more time for the drive to become ready. Also, you can try turning it down to see if a reset will help you along the way, but I'm not sure if that's the best thing to do or not. The next timer is the busy wait time, and we'll go back to the documentation. Right now it's set at 20 seconds. I'm not really sure how often this comes into play, but it's the amount of time in milliseconds to wait for the drive to become ready when performing an identified device command. Usually that's after an error when it's trying to perform the identify device command, just to see if the drive is still responding correctly. And again, it says if the timer expires, then a reset is performed. And usually there's already an error that it's waiting for, so it doesn't try to read the data again. I'm for sure on that one. And again, this is one of those timers, the busy wait time, that you probably don't normally want to turn down for any reason. Maybe you can find a reason to turn it down. You can turn it down as far as you want almost. I think it might be limited to 100 milliseconds. I can't remember. But it can't. It's one of those timers that doesn't hurt to turn up either. The next timer is the soft reset time. This is the amount of time, the initial amount of time that after sending a read command that the program will wait for the drive to respond, good, bad, or otherwise. If this timeout is exceeded and its default is 8 seconds, then a soft reset will be initiated. After the soft reset has been initiated, the next timer that comes into play is the hard reset time. That is defaulted at 800 milliseconds. If after the soft reset is started and 800 milliseconds go by, in this case, the hard reset time, the drive has not responded properly to the soft reset, has not come back around, then it will go to the hard reset sequence and it will initiate a hard reset. Now, in direct IDE mode, this timer will be grayed out because there is no hard reset. The hard reset would need to be performed with a modified ribbon cable and a relay to do a pin 1 hard reset, which is not implemented in the software and probably will never be implemented because there is no demand for it. Now, with this timer, in direct AHCI mode, if you set this timer, the hard reset time, to 0, it does something special. It skips the soft reset. It still uses a soft reset time. This is your primary time right here, the soft reset time. So after 8 seconds, it would perform a soft reset, except we made the hard reset time 0, so it's not going to perform, it's going to jump right straight to a hard reset. So it'll skip the soft reset. It still waits for the 8 seconds, but it actually performs a hard reset. The next timer is the reset timeout. And this timer, it waits for the drive to become ready or responsive after the hard reset has been initiated. It's the amount of time it waits defaults to 8 seconds. If this timer expires and the drive hasn't become ready, the default action is actually to do nothing. This is here in case you wanted to do something extra, like actually implement some sort of secondary relay that you could call on a command to actually perform a hard reset on an IDE drive. It is not typically where you would activate the primary relay to power cycle the drive. That's in a little bit different spot. You can use this as you see fit. If you have an issue with the drive not becoming responsive in a timely manner and you need to increase the time, you can turn this timer up. Not much reason to turn it down unless you're trying to speed things up, but turning it down could potentially cause some issues, I think. Okay, I mentioned the relay. So after the reset timeout, the app and it's set to do nothing, it actually will do something. It actually says that there is an issue with the drive, basically considered a major error, major drive error, because it's not responding anymore. So this is where you would actually tell it to activate the relay if you had a relay in play, if you had the relay. If you don't have the relay, it just stopped cloning with an error message. One little trick here, if you don't have a relay, or even if you want to have the relay and you want to try it, you can do a call command and sleep, say, 1 second. It'll sleep 1 second. Let's see if I can get the terminal to come up with this. I'm going to test the command. Took 1 second. Oh, it doesn't do anything in the terminal. I thought it did something in the terminal, but I guess not. Maybe that's only when it actually is running. Sleep 3. Now what this does is it'll disconnect the drive, sleep for a few seconds, probably only needs 1 second, and reconnect the drive. This has been found to actually work in some cases where a drive was unresponsive and you would think it needs a power cycle, but all it has to be is disconnected, wait just a little bit, reconnect, and then everything can resume again. So the next timeout is the general timeout, but in IDE and AHCI modes, this is an overall timeout. Meaning that even if you're waiting for any of these other timeouts to happen, if it hits this timeout, it stops with a major error. So the reality is you always want to make this higher than the sum of pretty much every other timer and then pad it a little bit. It doesn't hurt to make it at least twice as high as the value of all the other timers, so that if anything happens twice somewhere along the lines, it doesn't hit the general timeout and allows for all the other timers to do their job first. So the next thing is the phase timers. They're not enabled by default. You can enable them, and all of these timers override this soft reset time for the different phases. So by default, the way this is set up is phase 1 and 2 would have a 250 millisecond soft reset time. Phase 3 is 350. Phase 4 is 500. Trim or divide is 800. The second divide is 800. Scrape is 800. You can change these to whatever you want. You could make it so it's really fast in phase 1 and 2, to get the most good data first. That would be part of the reason you would do that. And then put the times way up for the other phases to try and get the most data out of the bad areas. That is the whole purpose of the phase timers. And again, these timers change the soft reset time per phase, so, and including the retry phase, which you see is all the way up to 8 seconds. That's what the phase timers are. Next timer option I want to talk about is always wait for reset timers. I actually pretty much forgot that I actually put this in here because I've never enabled it. I put it in here for some reason once upon a time, but what it's there for is to make sure that if you have a drive that seems to always need extra time after a reset, you can say always wait for the timer, which means it'll always wait. Well, you can see what it says here. Either the hard reset time or the reset timeout before checking if the drive is ready. It doesn't even try to check if the drive is ready until the next timeout is met. So that way, if the drive just needs more time to become ready, and if it, in case, say it shows that it's ready and then it goes busy again because it needs to do something or whatever, it's really not ready. If you check that, it can fix that issue. I'm not sure how often that issue occurs, but I must have put this in here for a reason. I would like to point out that the timer settings that have been discussed are primarily for direct IDE and AHCI mode. Direct USB mode timers will be discussed in a different video, as they are a bit different. Direct USB is a bit of a different animal. So now I'm going to give a few examples of how to change timer settings and for what reasons. This first drive is a testing drive that I've actually used the write uncorrectable command to write pseudo bad sectors to this drive based on an actual real drive case scenario. So it's going to be absolutely consistent for the testing. So we'll connect, start. Now what we're looking for is the time over here under current recent longest. Longest is like the longest time from the beginning of starting the program. Recent is probably, it's about within the last 5 minutes, the longest time, and the current longest time is since the last display update. And you can see we're pretty close to averaging around 3,600 milliseconds, just a little under 35 something. So we're going to stop it. We're going to go into the timer settings, and we're going to drop our soft reset time to 1,000 just because we can. So we're going to start it. Now, this is going to make things faster. You can see it's picking up faster. I didn't look at the actual read rate, but I'm sure it's a lot faster now. You can see it's around 1,100, a little over 1,100 milliseconds. So it's taken a little over 100 milliseconds to recover from the soft reset. And you can see over here in the console, it's doing soft resets. So it hits that 1,000 millisecond timeout, and it does a soft reset, and then it takes 120 milliseconds average probably before the soft reset is done, and then it's ready for the next read. This next drive is actually the original drive that my test drive is based off from, so it's really failing, and things are going to look a little bit different. So we'll start, and we're going to watch our times. Remember, we're at the default of 8 seconds, 8,000 milliseconds for a soft reset, so it's not hitting a timeout. And you can see over here it's not doing any resets. So our longest times seem to be a little over 3 seconds. Anything under that is probably reading good data. So we're going to watch this current time here for a little bit. You can see it's 3 seconds a lot, but let's watch for some other values. There's 500. That means it was a little slow. But it read data. There was a 1100, 2400. That was pretty close. A 1200. So a lot of those lower numbers are probably actually reading data and not airing out, because somewhere around 3 seconds is where this drive is actually saying it gives up and returning an error when trying to read. So we're going to stop this, and I'm going to change the timer settings, and I want it to go faster, so I'm just going to change the soft reset time to 800 milliseconds. Now it's going to cut off some of the data, like anything that could be read between 800 milliseconds and about the 3 second mark. That data is not going to be read because we're cutting the timeout short here. But I want to show something. Alright, we're doing soft resets, but it's also doing a hard reset because it's doing a timeout after soft reset. So the soft reset really isn't working, and it's still going way too high. It's at least double. You can see the 19. Oh, that's kind of consistent now. 1960. So a soft reset is at 800. The hard reset is at 800. So we're hitting that 1600 mark and then some, which means it's taking some time afterwards to recover from the hard reset. So we're going to stop this, and because I know the soft reset isn't working, it's not recovering from the soft reset in this 800 milliseconds. So I'm going to set the hard reset time to 0, which means it's going to, after this 800 milliseconds of the initial soft reset time, after that initial 800 milliseconds, instead of doing the soft reset, it's going to jump straight to a hard reset, skip the soft reset, because the soft reset isn't working, or at least does not seem to be working. So let's see what happens when I do that. I'm going to start. Look at that. Now it says it's doing a soft reset, but it immediately jumps to a hard reset if you look at the time here. So you can see that the time now dropped down to 1100, say 1150, 1160 milliseconds. Basically, at 800 milliseconds, it's trying to do a reset. So then it takes another 860 milliseconds. Wait, 800? No, 300. Excuse me. Let's do the math right. About 360 milliseconds or so to recover from the hard reset. So that's one way to tell, if you're looking at it, pay attention that if it's not responding to the soft reset and it's still going to the hard reset, you might as well skip the soft reset and go straight to the hard reset. So let's take a look at a totally different drive and see what happens. So we're going to connect and start. We got the default timer settings. I'm going to watch our times over here. Also watch, see if we got any, anything bad that wasn't read right. All right, so 8,014 milliseconds. We're at our 8-second timeout. It's doing a soft reset. You can see that over here in the console, and it's finding the marking things as bad or unrecovered. So let's stop it. So we're hitting our 8-second timeout. We also know that it's only taken a few milliseconds to recover from the soft reset. It doesn't have to do the hard reset. So the soft reset is working good. But we don't know the true nature of this. I mean, if we want to go faster, we would drop our soft reset time down to a low number so that it would skip out really fast. But for this, we just are interested to see if it reads any data at all and how long it does take to read data. So I'm going to just say 80 seconds for the soft reset, and just for simplicity I'm adding a 0 to the general timeout, which is a stupid high number, but I'm doing that for ease of use. So let's do start again, and we're going to see watch our timeouts, and also watch down here, pay attention to the numbers and see if the non-trimmed increase. We also want to watch bad just in case it doesn't, could potentially increase, and we'll see how it does. This could be a potentially long, slow, uneventful part of this video. Alright, 30 seconds. It read data. It took 30 seconds to read data, and it didn't add to the non-trim, so it didn't mark anything as bad. It actually read that data. It's a long time for a read, though. And again, another 30 seconds. There's no soft resets going on over here, no resets at all. So the drive is taking that long and then saying that it's returning data. Whether it's good data or not would be unclear. In this case, actually this drive does return good data if you let it read for an extensive long time in the bad head. Now, we wouldn't want to do this because it's taking forever, and the more time you spend working with the drive, the more likely it is to fail. But this is just, to show that if you turn that timeout up, you can see what the reality of, what's really happening with the drive. Is it reading, and how long does it take to read? And then make your decision on what timeouts to use and how to proceed based on what you see. So now that we've seen that this drive takes a stupid long time to read, if you put the timeout that high, and it actually timed out at 80 seconds on a read, and it failed. So we're gonna go back to the timing settings, and we'll take this down to 800. Matter of fact, let's go a little crazy and go down to 250 milliseconds in the soft reset, basically like the same thing as you have down here. And let's see what the difference is when we go to read. Well, it is interesting. It has taken 250 milliseconds to recover from a soft reset. If you could see that, it was about 500 milliseconds there when it was performing the soft resets. It's interesting considering that earlier when we were at 8 seconds, it only took a few milliseconds. But anyway, you see the results. It's reading much faster. It's skipping out of the bad head. You can see the skip numbers go out. go up, I should say, and that's what you would do to work with a drive like this with a bad head. You want to turn your reset times down good enough to skip out of it, and if it's not too insane like this drive is, you could try to come back after you go through phase 1 and phase 2 or whatever phases you want to go through, and see if you can dig into the bad head. And honestly, this drive is the reason I created phase 3, which actually because this drive actually has spots in the bad head that read decently for a short period of time and then go bad and take forever to read, and then starts reading good again. So actually, I got a lot of data out of this in the real world context when I process this drive. But you can see it's got severe issues, and you'd never be able to read all the data out of that bad head in any sort of reasonable amount of time because of how long it takes. So unless you do a head swap on something like this, you're just not going to read that data, and you have to give up on it. But this is a demonstration of how to use the timer settings to see what's going on in the drive and how to work with it and get the best result you can